Hello, I'm Norini, a chemistry teacher from Science Girls School, Seremban, Negeri Sembilan, Malaysia. I want to present a topic called stoichiometry. What a difficult and tongue-twisting word to pronounce. Can you all pronounce the word stoichiometry? So what is stoichiometry? Let's see how stoichiometry is used in our daily life, such as baking a cake. Now watch this scene where you can see that Mrs. Nurul is preparing a cake.
I'm going to bake a butter cake. I need 200 grams of flour, 250 grams of butter, 200 grams of sugar and 4 eggs.
Okay, Mrs. Nurul needs specific proportions of flour, butter, sugar and eggs to bake a nice and tasty butter cake. Without complete ingredients, the cake may collapse. Besides other added ingredients, Mrs. Nurul requires these main ingredients to bake a butter cake. 200 gram flour plus 250 gram butter, 200 gram sugar, 4 eggs to make one cake. Yummy! The butter cake looks so delicious. So, after watching Mrs. Nurul baking a cake by using a recipe, can you tell me what you think about stoichiometry? What is stoichiometry? Welcome back. What is your understanding of stoichiometry? As we saw from the last segment, the formula or equation used for cake baking describes the relationship between each ingredient and product so that we can use it to determine the amount of ingredients we need to prepare or the amount of the product we can get. Stoichiometry is the study of the quantity aspect of the chemical formulas and reactions. Stoichiometry involves the problem solving where you are required to calculate the masses of other reactants consumed and other products formed with the aid of a balanced chemical equation, given the mass of a reactant or product in a chemical reaction.
That cake is so yummy. Can you make one for my birthday party next month?
Sure, Zamil. I'm glad that the cake turns out well, although it was my first time attempt.
What are you doing, Mom?
I'm baking 4 butter cakes for your birthday party tomorrow. One won't be enough since we're expecting 30 guests. I'm going to get the ingredients that I need now. Oh my, I only have 200 grams of sugar. Is 200 grams of sugar enough to bake 4 cakes?
Can Mrs. Nurul bake 4 cakes with only 200 grams of sugar? How much sugar does Mrs. Nurul need to make 4 cakes? Can you do the maths for Mrs. Nurul? And now, let's discuss the answers to the activity. In the first place, of course, Mrs. Nurul cannot bake 4 cakes with only 200 grams of sugar. These are the possible solutions for the problem faced by Mrs. Nurul. From the equation of the recipe, 200 grams of sugar is needed to bake a cake. To make 4 cakes as we planned, the sugar is not enough and will be used up first. So here, the amount of the sugar will limit the amount of the cakes that we can make. So sugar can be called the limiting reagent, and we'll talk more about this concept later. So boys and girls, how much ingredients does Mrs. Nurul need to bake 4 cakes? To understand better, let's convert the recipe into an equation. Before that, Let's say 1 portion of flour, butter and sugar is equivalent to 100 gram. 1 portion of egg is equivalent to 4 eggs, and 1 whole cake is equivalent to 1 cake. Thus, the recipe can be represented as follows. This means 2 portion of flour, 2.5 portion of butter, 2 portion of sugar, and 1 portion of eggs are needed to produce 1 cake. Therefore, how many portions of flour, butter, sugar, and eggs are needed to produce 4 cakes? From the equation, to produce 4 cakes, you need to multiply the whole equation by 4. Therefore, 8 portions of flour, 10 portions of butter, 8 portions of sugar, and 4 portions of eggs are needed to produce 4 cakes. To know the amount, convert the unit of portion to gram and number of eggs and cakes. That is, 8 multiplied by 100 gram of flour, 10 multiplied by 100 gram of butter, 8 multiplied by 100 gram of sugar, and 4 multiplied by 4 eggs are needed to make 4 cakes. Thus, Mrs. Nurul needs 800 gram flour, 1000 gram butter, 800 gram sugar, and 16 eggs to make 4 cakes. So students, do you have similar answers? If you do, then excellent. If not, then you can discuss your difficulty with your teacher. Now, can you see how important a recipe, formula, or equation is when we are cooking, especially baking a cake? This recipe gives us the information about the relative amounts of the ingredients, which are flour, butter, sugar, and eggs, and the product, which is cake in this case. According to this recipe, we can determine how many cakes we can bake if we know the amount of each ingredient we have, or how much we need to prepare for each ingredient. Also, if we know how many cakes we are going to make. Next, to enhance your understanding on the concept of stoichiometry, let's think of other everyday examples where stoichiometry is used. Let me bring you back to the use of this baking cake concept in chemistry. Please remember, you need to apply the correct proportions. To refresh, in chemical equations, the amount is usually mentioned in mole. Do you remember in the last segment, we used the recipe to describe the proportional relation between the ingredients and the products? But in chemical equations, the coefficients represent mole. Therefore, the equation for Haber process in the animation can be described as 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. However, in the practice, we can't measure the reactants or products in moles. We usually measure them by the mass or volume. As you have learned before, the amount of moles can be converted into mass or volume. Class, do you agree with the answer given by your friend? Let's discuss the answer. If mole is converted to mass and volume, the equation can be described as the following. The chemical equation in terms of mass. As the relative atomic mass of nitrogen is 14.02 and the relative atomic mass of hydrogen is 1.01, therefore, 1 mole of nitrogen has a mass of 28.04 gram. 1 mole of hydrogen has a mass of 2.02 gram, and 1 mole of ammonia has a mass of 17.05 gram. Thus, the chemical equation in terms of mass is 28.02 grams nitrogen reacts with 6.06 grams hydrogen to produce 34.08 grams ammonia. Second, the chemical equation in terms of volume at room conditions, 24 dm³ of nitrogen reacts with 72 dm³ of hydrogen to produce 48 dm³ of ammonia. Now, boys and girls, I'll give you a situation. If 1 mole of nitrogen reacts with 6 moles of hydrogen, how many moles of ammonia produced? In order to solve this problem, you got to recall Mrs. Nurul's situation when she wanted to bake 4 cakes with only 200 grams of sugar. Although Mrs. Nurul has enough ingredients for baking 4 cakes, but if she has 200 grams of sugar, she can only bake 1 cake. This means Mrs. Nurul has limited amount of sugar. With this information, can you solve the problem above? As you can see, I've used the word limited amount of sugar in the example. This shows that the number of cakes can be baked depends on the amount of sugar. Since there is only 200 grams of sugar, therefore, only 1 cake can be baked. In a chemical reaction, the limited substance is known as the limiting reagent. Thus, in the activity that you have done, the limiting reagent is nitrogen. Therefore, only 2 moles of ammonia can be produced, although there are 6 moles of hydrogen. Now you know, the amount of product produced depends on the amount of the limiting reactants used. You might understand better about limiting reagent with the following example. Making cars. For each car, you need 4 wheels, 1 steering wheel and 4 doors. If you have 10 wheels, 2 steering wheels and 10 doors, what is the limiting reagent? How many cars can you get? Did you get the answer? From the activity, each car needs 4 wheels, 1 steering wheel and 4 doors. Since there are only 2 steering wheels, therefore 8 wheels and 8 doors are needed. Hence, the limiting reagent here is the number of steering wheels, and 2 cars can be produced because there are only 2 steering wheels. Now, let's try a simple activity to determine the mass of water can be made from 1 kilogram of fat tristearine in the camel hump. Your teacher will provide you with a handout. Work in groups to solve the question from the handout. Remember, when you want to solve problems related to stoichiometric relations, steps to be taken are: write the balanced chemical equation for the reaction if the equation is not given. Relate the given substance with the unknown substance based on the equation. Convert the given unit of substance such as mass and volume to the unit of mole. Relate the mole of given substance with the mole of unknown substance from the proportion in the chemical equation. Convert the mole of unknown substance to the related unit such as mass or volume. Determine the limiting reactant in this example. Lastly, do the calculation according to the amount of limiting reactant. In the activity, the chemical equation is given. You can use the equation to get the necessary information. 1. From the equation, 2 moles of fat tristearine can produce 110 moles of water. 2. Given 1.0 kg of fat, which is equal to 1000 divided by 266 mole. That is 3.7594 mole. 3. The number of moles water produced equals to 110 over 2 times 3.7594, which is 206.7669. Number 4. Mass of water will be 206.7669 times 18 grams. That is 3,721.8045 grams. Therefore, from 1 kilogram of fat, 3.7 kg of water can be produced. In this question, the limiting reactant will be the 1.0 kg of fat because the oxygen around the camel should be enough. Did you answer the questions correctly? Well done. If your answers are incorrect, you can further discuss them with your friends or teacher. Well, students, based on the activity you just did, hope you have realized that stoichiometry involves using a balanced chemical equation to determine the amount of products produced during a chemical reaction. An appropriate ratio needed to ensure how much of each particle is created relative to one another. This can be done through the stoichiometric coefficient. You can relate this to the baking cake situation earlier. To understand better the calculations, you can solve more problems with your teacher. You have seen the videos and carried out activities which are related to stoichiometry. From this lesson and activities carried out, I'm sure you have learned the meaning of stoichiometry and understand its concept. As you have seen, stoichiometry involves the writing of a balanced chemical equation which represents a certain chemical reaction. From this balanced chemical equation, amount of products could be determined when certain amount of reactants are used and vice versa. With the chemical equation, you can also determine the specific amount of product you want and then calculate the reactants required to produce the specific amount of product. This notion you could observe from the activities of Haber process, making cars, and water from a camel. From each activity, we could see that the amount of product produced is determined by the amount of the limiting reactant. You have also seen from the activity of baking cakes. When you need to prepare a certain number of cakes, you need specific amount of other ingredients in order to get the amount of product you need. If one of the ingredients is limited, the number of cakes could be baked depends on the limited reactant. I hope you have enjoyed the lesson in this video. Have a nice day and see you again. Thank you for choosing this lesson for your students. This lesson takes about 15 minutes to carry out. This video basically explains the meaning of stoichiometry and its importance in solving numerical problems. At the end of the lesson, your students should be able to use the balanced chemical equation to determine the amount of reactants needed to produce certain amount of product. Determine the amount of products produced from certain amount of reactants used and identify the limiting reagent. Students also can relate the concepts of stoichiometry in their daily lives. Please acknowledge, before watching this video, students should have prior knowledge on writing correct chemical formulas of compound, write balanced chemical equations, conversions of mole to mass and volume of gas, and vice versa, and relationship between number of mole and molarity. I would like to also suggest some activities you can use to conduct similar lesson. You can try problem solving with brainstorming session, carry out a simple experiment, and you may want to use mind mapping. Besides using the equation activities to produce ammonia from limited amount of nitrogen and to determine the number of cars that can be produced from limited number of steering wheels, the understanding of the limited reactant can be further explained by carrying out an experiment of reaction between marble chips and hydrochloric acid. Materials needed: marble chips, which is calcium carbonate, 0.1 molar hydrochloric acid with volume of 50 cm3. Apparatus needed are basin half filled with water, conical flask with delivery tube, and measuring cylinder 250 ml. Here are the procedures on how to carry out the experiment. First, pour 50 cm3 of 0.1 molar of hydrochloric acid into the conical flask. Then, fill the measuring cylinder with water and invert it into the basin filled with water. After that, adjust the end of the delivery tube into the measuring cylinder. Put in 2.5 gram of marble chips into the conical flask and immediately stopper the conical flask. Gently swirl the conical flask and record the volume of gas collected when the reaction has stopped. After finish, you need to repeat the experiment by using 10 grams of marble chips. Done with experiment, teacher guides the student to construct their knowledge of the concept, which is to construct the chemical equation of the reaction. Remember to tell the student that marble chips are actually calcium carbonate. From equation, 1 mole of marble chips reacts with 2 mole of hydrochloric acid to produce 1 mole of carbon dioxide. But for the first experiment, the number of mole of marble chips used is 0.05 mole and number of mole of acid is 0.025 mole. However, 0.025 mole acid can only react with 0.0125 mole marble chips. So, the 0.025 mole acid, which is the limited reactant, will first run out while marble chips is still in excess. The reaction will stop when acid is used up. Therefore, the amount of the product is determined by the amount of acid, not by the amount of the marble chips. So, only 0.0125 mole of carbon dioxide is produced. So, in a chemical reaction, the limiting reactant is the reactant that runs out first. If 10 grams of marble chips is used in the second experiment, still 0.025 mole of hydrochloric acid used to produce 0.0125 mole of carbon dioxide produced. Therefore, volume of carbon dioxide is 0.0125 multiplied by 24 dm cube, which is 0.3 dm cube or 300 cm cube. This shows that hydrochloric acid is the limiting reactant and marble chips is the excess reactant. Now you know the amount of product produced depends on the amount of the limiting reactants used. Here I give you suggested questions that you can ask your students based on the experiment. How many moles of marble chips react with how many moles of hydrochloric acid to produce how many moles of carbon dioxide? If 2.5 grams of marble chips is used to react with 0.1 molar hydrochloric acid, 50 cm cube, what is the volume of carbon dioxide gas released? If 5 grams of marble chips is used to react with 0.1 molar hydrochloric acid, 50 cm cube, what is the volume of carbon dioxide gas released? This is where your students will perform discussion and find answers. If you think the activities will require longer time, you can divide this video into 2 lessons. I would like to also suggest some problem-solving activities that teachers can use as handouts to complete the following equations by putting in the relevant values in the boxes provided. The following are the handouts that should be given to students to carry out the activities. These are suggested activities which you can use to conduct similar lesson in Activity 6. Teacher can also show that the lack of a certain reactant in a chemical reaction will produce products which are not as expected. For example, for the growth of healthy paddy plants, enough fertilizers are required. If the composition of fertilizers is not in the correct proportion, paddy plants may not give good yield of rice. Well, teachers, you can carry out a brainstorming sessions with your students to solve such problem.